Okay, so we were discussing this question in previous class. Okay, so these are all events listed. There was a urn, or there was a bag. In that bag, how many? Three white, three black, and two red balls were there. Three black and two red. Initially, we took out white. So for taking a white ball at the first, so total favorable outcomes are three. Total balls are there, so eight. So eight total outcomes. After we have taken out one white ball, now now there are only seven balls in the bag, and in which also there are only two white balls. Now for taking out another white ball, there are only two favorable outcomes. Okay, total number of balls are seven now, and for the red, two balls are there, two favorable cases, and total number of balls are six. So this is how this with the same logic we are going to find out with each and every case, and hence we'll be able to find out our answer. This is not a previous year question, but an example for making you understand the concept well. Is there any doubt?
No, sir.
Okay, let's move ahead. This is an important topic. Odds in favor and odds against any event. This is asked in questions directly, where you will be asked to find out the odds in favor or no odds against any event. So simply, when we used to find out the probability, we used to find out the number of favorable outcomes, or we can say that we used to find out that event can happen in how many ways. So number of events that event can occur. Okay, and we'll have to be used to divide it by the number of total ways it can, number of total possible ways. But this time, so if I write, let's say there are three possible outcomes: A, B, and C. Let me go back. Let's say there is a sample space of A, B, C, D, E, F, G, H, I, J. Okay. How many elements are there? There are 10 elements in there total. And we are discussing about an event of getting a vowel. A vowel. Okay. So how many vowels are there? 1, 2, 3. So number of favorable outcomes, 3. Total number of possible ways, 10. So if we had to find out the probability of the event, that will be 3 by 10. And if we have to find out the odds in favor, so how many in how many ways can our event occur? 1, 2, 3. Divided by number of ways that our event cannot occur. So if we exclude 3 out of 10, so basically we'll 10 minus 3 will divide it by 10 minus 3, because the remaining number of ways in which our event will not be occurring is the remaining other elements than this. Okay, so the answer will be 3 by 7 for the odds in favor. This is how we are basically going to find out. The number of sample space, the number of total possible outcomes, is equal to the sum of number of ways an event can occur plus the number of ways that event cannot occur. And thus this sum is going to be equal to the number of total possible outcomes. Okay, so that's how we are going to find out the number of ways that event cannot occur, just simply subtracting from the total. Is that clear, everyone? Is that clear, Yarini?
Yes, sir.
Let's take an example. If a dice is rolled, the odds in favor of rolling a 3. So number of ways event can occur rolling a 3, the only one way. So what is the sample space when a dice is rolled? It's 1, 2, 3, 4, 5, 6. There is only one way that event can occur. Okay, 1 divided by total minus that particular one event. So that becomes 1 by 5. Now let's move ahead to discuss odds against. Simply this time, we will reverse the formula. We'll have to write the number of ways an event can occur in the denominator and the number of ways that event cannot occur in the numerator. So for the same case here, the odds against will be 10 minus 3 divided by 3, that is 7 by 3. If you are shocked that how an odds against or odd in favor can be greater than or less than 1, yes, they can be greater than or less than 1 because they are not probability. It's not probability that we are discussing. It's not probability of event. It's simply odds against or odds in favor. Let's discuss this example. Using the same dice example, the odds against are rolling a 3. Against rolling a 3. So how many sample space have 6 elements? Okay. So the odds against, first of all, number of ways that event cannot occur, excluding the single case. So 6 minus 5, 6 minus 1, that becomes 5, divided by that number of ways in which event can occur. So there is only one way. So 5 by 1, it's the odds against. Clear?
Yes, sir.
Okay, so let's move ahead. We have already discussed about this. This is nothing, just saying that if you have to find the probability of event A happening or B happening. So we'll just use the set formula from the sets and we'll find out the probability using this formula. Now, if we try to understand this formula, how this formula is driven. So basically, we are discussing about when we will write A union B. So it doesn't matter whether it's there in the A set or B set, but just has to be there. And we have to find out that whether A event is occurring or B event is occurring, doesn't matter to us. We just have to find out the probability of occurrence of event A or occurrence of event B. So if I say there are 3 balls, if I say there is a bag, okay, and there is a red ball, there is a blue ball, and there is a green ball. And now if I tell you to find out the probability of getting a red ball, that will be 1 by 3. Probability of getting a blue ball, that will be 1 by 3. Probability of getting a green ball, that will be also 1 by 3. But if I say probability of getting a red or blue ball, that will be definitely greater than the probability of getting a red specific ball, right? Because uh, whether can we get a red ball or a blue ball. And now if we will subtract the happening of event R and B simultaneously, but that cannot happen because we are only getting one ball out. So that is minus 0 because that's unsure event. So 1 by 3, 1 by 3 makes it 2 by 3. So we can see here the probability of event R getting a R ball, red ball or a blue ball is almost double than the probability of getting a red ball uniquely. Clear?
Yes, sir.
Yes. And here C means complement, and whenever there is such alphabets written simultaneously like probability of AB, it means probability of A O intersection B, and which is meaning that probability of A event and event happening simultaneously. A and both A event and B event should happen simultaneously, and they both of them should occur. Whether we were discussing about R or B, A or B, so it meant that whether event A, occurrence of event A or B, anyone can work. But here we are discussing about occurrence of event A, both, I should write both event A and B. That is the difference. Okay. There are same formulas as there were in sets. AB, don't confuse it with that this is something else. This is just another representation of A intersection B, right? And we have already discussed earlier that probability of A intersection B is probability of A into probability of B in case of when A and B are independent events. Okay. And also keep one more thing in mind, that when A and B are mutually exclusive events, this is important, then probability of event A and B happening simultaneously is 0. Why? Because they are disjoint sets. They are disjoint events. If A will be happening, then it will be certain that B is not happening. If B is happening, then it will be certain that A event is not happening. Why? Because the occurrence of one rules out the possibility of the occurrence of second event, the other event. Okay, they are disjoint sets. There is nothing in common. They cannot happen in a continuum. They cannot happen simultaneously. Is that clear?
Yes, sir.
Let's now discuss some examples. So a dice is thrown. What is the probability of getting a prime number? Now let's solve it. If a dice is thrown, so sample space is basically 1, 2, 3, 4, 5, and 6. The favorable outcome is, how many prime numbers are you able to spot in this sample space?
Three, sir.
Which one? Right? Which
2,
one?
3, 5.
Yes, very good. These are the three prime numbers. Okay, so there are three number of favorable outcomes. So if you have to find out the probability of this event, this will be 3 by how many total number of outcomes are there?
6.
Yes. So probability will be half. There are 50% chances to get a prime number on the dice. We throw a dice. Okay. Let's now discuss one more easy question. A fair coin is tossed twice. Probability of getting head in both trials is that what we have to find out. Now, first of all, let's understand the question. What is a fair coin? Fair coins mean that the possibility of getting a heads or a tails is equal. Okay? If we find the probability of getting a heads, it is equal to the probability of getting a tails. That's what a fair coin is. Now, the coin is tossed twice. So the same sample space will look like first it can give us head and then head, or maybe head and tail, or maybe tail and head, or maybe tail and tail. Four possible outcomes. Do you agree? And are you able to understand how we have written them?
Yes, sir.
Hmm. Now, probability of getting a head in both the trials is this is the only favorable outcome, right? So the probability of this event is 1 by how many? 4. Clear? Is that clear?
Yes, sir.
Yes. There's also one more method in which we can solve this question. Let's discuss the same on the next page. So there were two events happening, and our desirable event was having head and head here on both of the places. And how many chances are there for like to filling this? For the first event, there can be two events. For the second event also, there can be two events. Total number of outcomes is this 4, out of which we need a specific outcome like this head and head. Okay, with head and head, there can be no more. There's only one favorable outcome that can be there out of 4. So we could have just written directly 1 by 4 using this analogy also. Otherwise, if we just observe head and head, so the possibility of getting a head is half, multiplied with the possibility of getting another head is also half. It's 1 by 4. There are multiple ways to approach the same question. Are you able to understand all three approaches?
Yes, sir.
Great, great. So now we will discuss same kind of question, but a little bit more difficulty, or let's say with more concepts. The coin is tossed, tossed thrice. Successively thrice. We have to find out the probability of getting one head or two tails. Okay. So there are also multiple approaches, but let's start from the basic one first. Let's list the sample space. So coin is tossed thrice. Of course, there will be 8 number of outcomes. We'll write H, H, H 4 times. Tail, tail, tail 4 times. Head, head 2 times. Tails, tails 2 times. Head, head 2 times. Tail, tail 2 times. Head, tail, head, tail, head, tail, head, tail. These are 8 outcomes. We wanted one head or two tails in the every case. So is there one head? Yes, there is one head. So we'll count this case. Is there is one head? Yes, there is one head. Wait a minute. I have written the question in a slightly wrong way. It is asked about two tails, one head or two heads. Not two tails. It will be one head. Probability of finding one head or two heads. Okay. Now let's look. Is there is one head? Yes, there is one head. Is there one head or two head? Two head. That also works for us. Two heads works for us. One head works for us. Two heads works for us. One head works for us. One head also works for us. No head doesn't work for us. At least there should be one head or two head. This is the case which we have to exclude this time. Okay. Now there is one more. There is one more thing to consider in this question. What is that? We wanted one head. That means that head plus two tail. This works for us. And in any scenario, THT, this is also works for us. Two tail head, that also works for us. When we needed two heads, so two heads only, like exactly two heads. Head, this works for us. Head, tail, head, that also works. Head, tail, that also works. Okay. So oh, I have written it twice. Tail should come first this time. Tail, head, that also comes works for us. But not three heads. Why? Because it's not a condition. It's not the condition that we are looking for. We are looking for exactly one head or two head. Okay. So this case will also be excluded from our consideration. Are you able to understand why?
Yes, sir.
Yes. So number of favorable outcomes, 6. Total outcomes, 8. Probability of the event is 3 by 4. Is that clear? Is that clear? Let's go with another approach. We knew that we wanted probability of getting a head, one head. Okay, so if there are three places, so a head can be placed on three places, right? So first let's find out. We have to select. We have to select one head and replace on three places. Okay, okay. And other than that, there has to be tails. So just by writing one head, I get to know that there will be two places, two tails there will be, and the total number of arrangements will be here 3 factorial. Okay, divided by 2 factorial because of the repetition of tails. So that makes it 3 arrangements. Okay, 3 arrangements. Okay, we got it. Now, now let's find out their probability. Its probability will be half. Probability of getting a tails is also half. The probability of getting tails is also half. Its probability is 1 by 8. Okay. With 3 arrangements means this can happen thrice. So, or basically overall probability of the event of getting one head on any of position that this is precisely about this. So this will be repeating in 3 ways. So we can write probability of getting a head is one head is 3 by 8. Okay. Are you able to understand till now?
Yes, sir.
Let me create some space. Now let's discuss about probability of getting two heads. Now two heads and then tail. Three places. Now we are finding out for the total number of cases, total number of arrangement. Three places, but head is getting repeated twice. So there can be three arrangements made. How many what is the probability of this particular case is half into half into half, that is 1 by 8. This is exactly the probability of this case HHT, whether uh, the case is having two heads can be arranged with three. So the probability, or let's say we can just write them that head tail head or tail head head, these also can be the cases, and each and every one's probability will be 1 by 8. So that's why we will write the probability of getting two heads is also 3 by 8. Now we are referring and we are unifying both of the cases by or. So 3 by 8 plus 3 by 8, okay, minus when one head and two head are occurring simultaneously. So is there any case where on three places there is one head and also two head occurring same time? No, there is not any. Because when there are two heads, there are two heads. When there is one head, there is only one head. So there is no common ground. So probability of, let's call it event 1, let's call this event 2, of event 1 and or event 2 happening simultaneously is 6 by 8, which is 3 by 4, which is our answer. Is that clear, everyone? Is that clear, Yajni?
Yes, sir.
So the fundamental principle of counting is working here also. Now let's move ahead. Okay, as we were discussing about dice, there will be certain questions which will be referring to dice numbers, and there will be some terms used, mathematical terms used, and it would be better for us if we discuss them right now. These are at least and at most. Can anyone tell me the difference? What is the difference between at least and at most?
Sir, at least means it is minimum, at most means maximum, like that.
Yes. Let's say there is a number line, okay, and the number line is having only few numbers on it: 0, 1, 2, 3, 4, 5, 6, and our number line is limited to to the numbers that are there on the number line itself. If I say ki at least 4, then which numbers are you going to consider on this number line? Only integers. Come on, try. There's no problem if you give wrong answers. At least 4 means we'll start from the very basic, from the ground, from the 0, and we can go till 4. No, that's wrong. That's wrong. At least 4 means at least 4 means at the minimum it can be 4 or greater than the 4. That is at least 4. This range with the arrow. This is representing at least 4. The minimum of our range is 4. The minimum of our range is 4 here. And when we discuss about at most 4, this is at most 4 means maximum is 4 starting from 0, and at least 4 means starting from 4 and going towards the bigger digits or the infinity plus infinity, right? So if I write at least 1 or at least 4, let's say here, then it is total minus total, that is total is 0 to 6, so that's total minus 0, the case of 0, 1, 2 and 3. At least 4 means this only, na? 4 is included. If I write at most 4, so it means total minus, another way of saying this is total minus excluding the cases of 5 and 6, right? I just want you to understand the meaning of at least and at most. This is not important, but this is just a representation that if we have to find out if and there is some total value defined, so we'll be able to find out at most and at least using this analogy, that when total is defined, and it will define in case of dices, and we are going to look on the questions. Is the difference between at least and at most clear?
Yes, sir.
Okay, let me look for some examples. Yes, I found one. Let's discuss the same. So the case is 3 dices are thrown together. the probability of getting a total of at least 6 is what we have to find out. So this time, the understanding of ours that let's go back on the slide. That total is equal to the at least. Basically, total is equals to at least, sorry, at most x plus at least x. This is looking absurd, I know, but once we discuss this question, it will not be looking further any stranger. Okay, so 3 dices are thrown. The probability of getting a total of at least 6. So probability of getting a total of at least 6. 3 dices are thrown together, and everyone has possibility of 1, 2, 3, 4, 5, 6. These are the faces of dice every time. Every time. So at least 6 means it has to be 6 or 7 or 8 or 9 or 10, means 6 is the minimum number and the maximum that you can reach. What is the maximum number that can be reached by summing 3 dices numbers? If we maximize all the dices 6 and 6 and 6, that becomes 18 is the maximum number, maximum sum that can be possible after observing numbers by throwing 3 dices. But now you can see this is a lot number of cases, right? If we go on to solve these cases, we'll not be able to find the answer in time. Yes. So instead of finding the probability of getting at least 6, what we will do is that we'll find out 1 minus probability of getting the sum at most 6. Okay. Now we'll be able to find out it easily. Why? The minimum sum can be 1 plus 1 plus 1. Why 1? Because 1 is the least possible number that can be there on the dice, not 0, because there is the least possible number, that is 1 only. So the least possible sum is 3, 4, 5 or 6, at most 6. Okay. How 3 can become? Only when there is 1 on the first, 1 on the third, 1 on the second. How 4 can become? 1 plus 2 plus 1, or 1 plus 1 plus 2, or uh, I should write over here, or 2 plus 1 plus 1. So there are 3 cases here. How 5 can become? 1 plus 1 plus 3, and it's 3 arrangements. Okay. Or it can become by 2 plus 1 plus 1. It's 3 arrangements. No, 2 plus 1 plus 2. It's 3 arrangements. Because of how we are able to find out that which number of arrangements it will be there, by simply multiplying 3 factorial, 3 numbers, 3 places. But one number is getting repeated twice. So that's why 3 arrangements for this one also, 3 arrangements for this one also. That's how we are able to find it out. Okay. 5 can be made out by 3 plus 1 plus 1. Yes, we have already considered that. 2 plus 1 plus 2. We have already considered it. Okay. No other possible 3 numbers can make 5. Okay. Let's discuss about 6. 1 plus 1 plus 4. It's 3 arrangements because of 3 places, 3 numbers, but 2 repetitions. It's 3 arrangements. Or 2 plus 2 plus 4. So 2 plus 2 plus 2. No arrangements of this. Why? 3 factorial, 3 numbers, 3 places, but 3 repetitions also. So only no arrangement for this number. Okay. So or 2 plus 1 plus 3. How many arrangements? 3 factorial. No repetitions. So 6 repetitions. 6 arrangements for this 3 numbers can be arranged like 2 1 3 or 1 2 3 or 3 2 1 or uh, 1 2 3 or 1 3 2 or 2 1 3 or 2 3 1 or 3 1 2 or 3 2 1, like these 6 arrangements. Hmm. Oh, and is there any other number that can make 6? 2 plus 1, 2 plus 4. So 2 plus 3 plus 1. Okay, done. 2 plus 2 plus 2. Okay, done. And okay, that's only 1 plus 5. So 1 plus 1 plus 4, 1 plus 2 plus 3. That is also done. 1 plus, okay, that's the only case. I guess we are done. Yes, we are done with all the cases. Now let's find out the probability of finding getting at most 6. So how many cases are there? Let's find out the total number of favorable outcomes for finding out the probability of getting a sum at most 6. So there's one case here, 2, 3, 4. These are 3 cases. Right? Remember, these are 3 cases. 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. 13 plus 1, 14. 14 plus 6, 20. Okay. 14 plus 6, 20 cases. So these are 20 cases. Let me repeat the counting. Are we doing any mistake or not? No, we are not doing any. Till now, 1 to 4. 4 plus 6, 10. Okay. At most 6 means, whether 6 is included or not here, that is one doubt. Can you tell me, is 6 is included or not? See, when we are writing total at most x and at least 6, then the particular point here 4 cannot be included twice, right? 4 can only be included with one quantity. So we will include 4 with at least, and in the case of at most, we'll exclude the case of 4. Okay? We are not going to include the case of 4. Is that clear, everyone? So here at most 4 means total number of cases minus 4 also, because we are also excluding the 4. Clear? Otherwise, it will be counted twice. Okay. So here also we are not going to include 6, otherwise it will be a mess. Then we are also going to consider 6 case in at least 6. Then we are going to uh, calculate the number of cases for 6 twice. So this time 1, 2, 3, 4 plus 1, 2, 3, 4 and 3, 7, 7 and 3, 10. So how many total cases for getting a sum at most 6 is 10 divided by total number of possible cases 6 raised to power 3. 1 minus, and that is the probability of at least 6. Getting the sum at least 6. That becomes 1 minus 10 by 36 into 6 becomes 216. 216 minus 10 divided by 216 is 206 divided by 216. If we divide by 2, 103, 108 is our answer. Is there any doubt? Please reread the question. Is there any doubt?
No, sir.
Okay, so let's discuss one more question. The question is, if two dice are thrown simultaneously, and throwing a dice repetitively for 2 times or throwing 2 dice simultaneously are just the same. There's no much difference. Then we have to find out the probability of getting a total of 7. Okay, if there are 2 dice, so the range for every place has choices 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we want the sum as to be 7. That can only happen when 1 plus 6, 2 plus 5, and 3 plus 4, and 4 plus 3, and 5 plus 2, and 6 plus 1. So basically, how many favorable cases are there? 6 divided by 6 square. That's the probability of event. Very easy. 1 by 6 is the answer. Any doubt?
No, sir.
Yes, it's very easy. Probability is very easy to understand.